Good morning, children. In this class, we are going to discuss about mole fraction, the second term to represent the concentration of solutions. Now, let me see first of all definition. So, very simple to give a definition here. The ratio of number of moles of one component to total number of moles of all the components present in the solution. Ratio of moles of one compound and total number of moles of all the components, isn't it? For example, you are having a solution with A plus B. Okay. Now I want to calculate mole fraction generally represented by X. I want to calculate mole fraction of A. Means what is mole fraction? So number of moles of A divided by total number of moles Na plus Nb. Total number of moles. Now it is called what? Mole fraction, isn't it? So we take some example in a binary mixture. If number of moles of A and B are represented by Na number of moles of A, Nb number of moles of B. Now what will be the mole fraction of A? Just now we discussed here number of moles of A divided by number of total number of moles Na plus Nb. Isn't it? Similarly, if you want to calculate, isn't it, mole fraction of B, how to calculate mole fraction of B here? Mole fraction of B is equal to number of moles of B divided by number of moles of A plus number of moles of B here. In this way we can calculate mole fraction of B here. Now for a solution containing n number or I number of components, in that what will be the formula here? For x1 to calculate mole fraction of 1, so n1 by total number of moles, n1 plus n2 plus n3 plus total number of moles, isn't it? Then we get mole fraction of x1 here. This implies what actually? Total number of moles of solution. Total number of moles of solution, isn't it? Means number of moles of 1, number of moles of 2, number of moles of 3, like that is it. The sum of mole fraction of all components always will be 1 only. It will be unity. Means what? 1. That means when you take, for example, mole fraction of A plus mole fraction of B, always should be 1. Otherwise, mole fraction of 1, mole fraction of 2, mole fraction of 3 or plus dash dash, it always should be 1 only, isn't it? So even though if we have n number of components in the solution, the mole fraction of all the components should be always equal to 1 only. In this case, you can also, if for example you calculated mole fraction of A, I want to calculate next mole fraction of B. How to calculate? Mole fraction of B is equal to 1 minus mole fraction of A actually. In this way we can easily calculate here. Next, what is some important topics here about mole fraction here? It always relating some physical properties of solution like vapor pressure, isn't it? So it is useful in vapor pressure type of problems here, and it has no units. Why? Because when you take formula here, what happens? The formula number of moles of A by number of moles of total solution. Now moles get cancelled. No, the units for mole get cancelled, so it will be unitless. Next, here whatever we are taking that in terms of solid nature, okay, because mole is equal to what actually? Weight by molar mass or mass by molar mass. Mass always in terms of grams, so that should be in the form of what? Solid nature. So generally they do not depend upon temperature. Only solutions will depend upon temperature. So it is independent of temperature. There is no change in the concentration. That means mole fraction never changes with respect to temperature, right? Why? Because mole fraction you are representing in terms of what? Solids only, in terms of grams, so they never change with respect to temperature. Temperature means what? Not elevated temperatures. at normal temperatures here. Next, number of moles. Something will take formula. Just now I told you formula will be number of mole is equal to weight by molar mass or gram molecular weight, isn't it? One relation is there, mole percent also we can calculate by just multiply mole fraction with 100, isn't it? We get mole percentage also. This is also very important formula. Mole percent is equal to mole fraction into 100 actually. So this is very important formula you need to remember. Weight by gram molecular weight or mass by molar mass actually. We'll see some number of problems are there. We'll see all these problems here. Now they are asking calculate mole fraction of H2SO4. This we need to calculate. Now what they given in this case, 98% of H2SO4. Meaning of that one, 100 gram is solution, weight of the solution is 100 gram and weight of H2SO4 will be 98 grams here. The weight of H2SO4 is 98 grams and the weight of solution always will be 100 only, isn't it? Next, what is weight of water? See, the solution is made up on by actually H2SO4 and water. See, the solution is actually here what you are having, one component is what, water, and other component is what, H2SO4. Solution weight is how much here? 100 grams. Now H2SO4 weight is how much? 98. Now what will be the weight of water now here? Definitely it will be 2 grams only. So you got weight of water and you got weight of H2SO4. Now you have to calculate first of all number of moles of H2SO4. Now that means what is the formula? Weight of H2SO4 by molar mass of H2SO4, isn't it? Otherwise gram molecular weight of H2SO4. Weight of H2SO4 is given 98. Gram molecular weight of H2SO4 always will be 98 only, because H2SO4 here what? 2. Sulfur will be 32 and oxygen will be 64 because 4 oxygens are there. 16 into 4, 64 here, right? So total we are going to get 98. So number of moles of H2SO4 should be here 1 only. Now next we calculate number of moles of water now. Number of moles of water means weight of water divided by molar mass of water, isn't it? Now weight of water, how much we got in the last that slide 2, right? What is the gram molecular weight of water? 18. So we are going to get how much here? 1 by 9 here, isn't it? Now we got mole fraction of H2SO4 formula will be number of moles of H2SO4 divided by number of moles of H2SO4 plus number of moles of water, isn't it? So here this will be the number of moles of H2SO4 and this will be same number of moles of H2SO4. Here number of moles of water. That means total moles of solution, isn't it? Now substitute here number of moles of H2SO4 we got 1 and again 1 plus 1 by 9. So if you substitute this one we are going to get the 0.9. So mole fraction of H2SO4 will be 0.9. Now how to calculate mole fraction of water now? If they ask what happened, mole fraction of water will be, so number of moles of water by number of moles of water plus number of moles of H2SO4. But this formula not required for it. Not required. Why? Because we already know mole fraction of H2SO4 plus mole fraction of water is always should be equal to 1. Now mole fraction of water will be how much here? 1 minus mole fraction of H2SO4. That will be 1 minus 0.9 is equal to pi. If you do this one problem also, if you do like this, so how much it is? 2 mole fraction of number of moles of water will be how much here? 1 by 9. Substitute here 1 by 9. Substitute here 1 by 9 and mole fraction number of moles of this one will be what? 1 only. Substitute here you will get the same answer only. Next, one more question. A solution of sucrose in water is labeled as 20%. What will be the mole fraction of each component in the solution? So here Sucrose in water means what? Weight of sucrose is 20 grams. Okay, the mass of sucrose will be 20 grams here. Next, molar mass of sucrose that I will give you, that is molecular weight is C12H22O11, means 12 carbons, 22 hydrogens, 11 oxygens. That should be 342 grams, isn't it? Molar mass will be 342. Next, mass of water is given? No, but 20 grams if it is sucrose, remaining will be water only. That means how much it will be? 80 grams, isn't it? So mass of water always should be 100 minus 20, that equal to 80 grams here, isn't it? Because solution is made up on with sucrose and water, isn't it? Sucrose and water here. If it is 20 grams, this definitely it will be 80 grams. Total equal to what here? 100 grams here. Now what you need to calculate now here? Molar mass of water will be 18, that is same only. Now what we need to calculate here? Number of moles of sucrose, that means weight of sucrose 20. Molecular weight of sucrose 342, that you are going to get here 0.0585 moles here. Next, number of moles of water is equal to 80 by 18, that will be something you are going to get 4.45 moles. Now total number of moles equal to what? Number of moles of sucrose plus number of moles of water. Now how many we get? Number of moles of sucrose 0.0585 plus number of moles of water will be 4.45. Total number of moles, how much you are getting? 4.5. This you should be in where? In denominator, always in the denominator. Next, I am calculating mole fraction of sucrose equal to number of moles of sucrose by total number of moles. That will be 0.0580 by 4.5, that will be 0.013. Now we need formula now? No. Mole fraction of water, generally formula we can take, okay, but not required here. The formula is not required. The same 0.987 you will get in this manner also. How? Mole fraction of sucrose plus mole fraction of water is always equal to what? 1 only. Now how much we got here? 0.013. Now I am calculating mole fraction of water, that is equal to 1. Now mole fraction of water will be how much here? 1 minus 0.013. What answer you are going to get? 0.987. Same thing we are going to get here, right? Next, one more question. Calculate the mole fraction of benzene in a solution containing 30 grams of mass in carbon tetrachloride. You take this as a homework, but I will give the molecular weight for this one. So mass of the solution, how much it is? Again 100 grams, right? Next, mass of CCl4, how much it is? 30 grams, right? Sorry, it is 30% mass in carbon tetrachloride. So they are saying what? Benzene. So mass of benzene in a solution containing 30%. That means this is mass of benzene will be how much here? 30 grams here, right? And mass of carbon tetrachloride will be remaining how much here? 70 grams here. So you got mass of CCl4 and mass of benzene you got here. And this is the mass we are going to get as a 30 grams. Now molecular weight of CCl4 how much here? Carbon is 12, chlorine 1 is 35.5, multiply that one into 4, you will get 154 here. Molecular weight of benzene will be 78. Now you have to calculate here mole fraction of benzene. We'll take a multiple choice question. Next, sum of the mole fractions of all the components always will be. If anybody can answer here, you take this one as a exercise. The previous one also you take as exercise here, okay? Take as assignment. Sum of the mole fractions of all components will be less than 1 or greater than 1, less than or equal to 1 or 1. You have to make a. Next, one more problem if we take 44 grams of carbon dioxide and 14 grams of nitrogen, what will be the mole fraction of carbon dioxide? 1 by 5, 1 by 3, 2 by 3, 1 by 4. So this you need to take assignment here. Take this one as assignment, right? Take this one as assignment here. So with this what happened? We have completed